Hi. In this video, we are going to do a nice geometry problem. It should help you understand some of the concepts involving circles. So the question says, a circle is inscribed in a triangle with sides 3, 4, and 5. A second circle interior to the triangle is tangent to the first circle and to both the sides of the larger acute angle of the triangle. Now the question is, if the radius of the second circle can be expressed as sine k by cos w, where k and w are in degrees and lie between 0 degree and 90 degree, you have to find the value of k plus w. So basically you have to find the radius of the second circle. So first thing to notice here is the triangle has sides 3, 4, 5. So it's a right angle triangle because 3, 4, 5 are Pythagorean triplets. So first of all, we have an in circle to a right angle triangle and then a second circle inside it. Let's draw a figure here. So let this be the bigger side 4, let this be the side 3, and this is the hypotenuse. And let's label it as A, B, and C. This side has length 4, this side has length 3, and this side has length 5. And this is obviously 90 degrees. So first we will have to draw the in circle. So let's say our in circle is somewhat like this. And the in circle is the point of intersection of angle bisectors. Now our second circle was said to be tangent to the first circle and to both sides of the larger acute angle of the triangle. So you should remember basic geometry that the angle opposite the greater side is bigger. So the angle opposite the side 4, which is angle C, will be bigger than the angle opposite the side 3, which is the angle A. So the larger acute angle is this angle, and the second circle is going to touch the sides which contain the larger acute angle. So it's going to touch basically AC and BC. So we'll draw our second circle like this here. It is tangent to this circle and is also touching these two circles like this, right? Okay. Now remember that this circle is touching this side and is touching this side. So this distance and this distance are equal. These are the radiuses of the smaller circle, small r and small r. So you should realize that this center is also on the angle bisector of angle C. Why? Because any point on the angle bisector is equidistant from the sides AC and BC. So we have a straight line from the center in center to this point to this. So this is, let's label it as D. So D is the center of my smaller circle and it's a straight line from I to D to C, because D also must be on the angle bisector because point D is equidistant from the two sides AC and BC. Right. And now we have, this is my in radius, and this is also in radius, by the way. Now think about it. you can easily see that there is a similarity happening here. This angle will be C by 2 because it's angle bisector. And if I draw a parallel line like this angle will also be C by 2, right? Because this line will be parallel to this line. Why? Because both this is perpendicular to BC and this is also perpendicular to BC. So this line is parallel to this line. Therefore, I have here this angle of the triangle is becoming C by 2. You must understand why that is true. You can prove it by similar triangles. If you label everything, you can say IF and DE are parallel lines because they are both perpendicular to the same side. And if IF and DE are parallel lines, then automatically you are getting the fact that this angle, for example, will be equal to this angle and so on, right? And you will get this is 90, this is 90. So the triangles are similar. So therefore, this angle C by 2 is also this angle C by 2. Now focus your attention on the triangle here. We have this sort of a situation happening. This was the radius of the second circle and this was the in radius. So I should label it differently. So if small r is the radius of the smaller circle, and this is the in radius, let's label it as capital R for now. What I can say is that I know C by 2 is the angle here, right? So I also know the distance between the centers, the hypotenuse. Because the two circles are touching, the distance between their centers will be r plus smaller, right? So in this right angle triangle, I can say this much would be r minus r, right? This much is r minus r, and this distance hypotenuse is r plus r. So I can easily write sine of C by 2 is equal to r minus r by r plus r, right? That is a relationship that I have. Here capital R is the radius of the in circle. Now using your concepts of properties of triangles, you should realize that in circle radius small r would be equal to del by S, where del is the area of triangle ABC and S is the semi-perimeter of triangle ABC. That will give us the in radius of triangle ABC, right? So area of triangle ABC is simple. It is half into 4 into 3 and semi-perimeter is half into 4 plus 3 plus 5, right? So basically you're getting half gets cancelled. You're getting 12 by 12. So capital R is equal to 1 and that is the in radius of this big circle. The radius of that circle is 1. So now I get the relation sine C by 2 is equal to 1 minus R by 1 plus R, right? And since the triangle sides were known, I can easily find sine C by 2, right? So let's do that on the next screen. So I have sine of C, the triangle was like this. This was 4, this was 3, this was 5. So sine of C is 4 by 5 and cos of C is 3 by 5. And I want to find sine C by 2. So I can use cos C and write it as 1 minus 2 sine square C by 2 using half angle formula is 3 by 5. So 2 sine square C by 2 is equal to 2 by 5 and sine C by 2 is basically becoming 1 by root 5. So if sine C by 2 is 1 by root 5, from the previous derivation we have seen sine C by 2 is r minus r by r plus r and the in radius was 1, so 1 minus r by 1 plus r and we are getting 1 by root 5 is equal to 1 minus r by 1 plus r, right? Once we get this, it is obvious to find r. You can do componendo and dividendo and find r to be equal to root 5 minus 1 by root 5 plus 1. And now that is the radius of my smaller circle here. Once we have this, we have to express it in the form of sine of some angle k by cos of some angle w. And you should know these basic angles. Sine 18 degree is root 5 minus 1 by 4. And cos 54 degree is root 5 plus 1 by 4. These are two basic trigonometric ratios that you should know. If you don't know it, you can derive it easily. So try to find the derivation of sine 18 degree, how to find the value of that. It is there in SL only. The idea is to take theta as 18 and do 5 theta is equal to 90 and split the 5 theta as 3 theta and 2 theta and get a cubic equation. So try it out yourself or check it out from SL only, but you need to remember these basic values. So from here, we can easily see that R is equal to sine 18 by, actually I have made a mistake. It is not cos 54, it is cos 36. This value is cos 36 degrees root 5 plus 1 by 4. So check out the values yourself and see whether what I'm saying is correct or not. So sine 86, sine 18 by cos 36 is your R, and K plus W is therefore 18 plus 36 is equal to 54. And that finishes off the problem for us. So hopefully you've learned something from this video. It involved in circles, a little bit of properties of triangle, also drawing the two circles together and finding the distances by applying Pythagoras theorem and geometry. So very important that you learn these ideas. I had done a similar problem a few days ago, so you should check that out as well, where we drew multiple circles tangent to a common tangent, right? So try out that problem, problem 90 or 91, I think it was. You should check that one out as well. So that's it for this video. I'll see you next time.